Hello everyone, my name is Raghavendra Ramachandra. I am from Norwegian University of Science and Technology, Norway. So in this work, we try to benchmark different face morph attack detection algorithms to study their fairness for different demographic data. So outline of my talk is as follows. So first I will provide a very brief introduction on face recognition as well as face morph attacks, and then I will give the very brief introduction on the face morph attack detection techniques which are existing today. So then I will provide in details about our newly constructed database, especially within the scope of this work, and we name the database as mixed ethnicity morph dataset. So then I will report several quantitative results that we have designed to give insights on different morph attack detection algorithms and their variation in the detection performance, especially with different demographic data. Based on the obtained results, I will also present several discussion and then we can draw the conclusions. So as we know that the face recognition systems are widely deployed and employed in several types of application, and today the face recognition system has become an integral part of our everyday life. The face recognition system has been used in a very trivial applications such as unlocking the smartphone till the very complex and highly secure applications such as border control systems. So when we consider the face recognition system, especially in the border controls, so there is a recommendation from ECO to use the face biometrics as the primary identifier, especially in the e-passports. So as a result, there are more than 800 million passports which are deployed with face biometrics. So as the face biometric system has become prominent in our everyday life, so attacks on the face recognition system also exponentially increased. So however, there exist several types of attacks. The attacks on the face recognition system that can be broadly classified as direct attack and the indirect attack. Within the scope of the direct attack, so the most prominent type of attack is based on the presentation attack detection, and the other kind of attacks is the face morphing attack. So in case of the face morphing attack, attacker can use two face images. For instance, as you see in this slide, the subject 1 and the subject 2. So then we can perform the morphing operation on the subject 1 and subject 2 to get the morph face image. The interesting thing about this morph face image is it is difficult for both human observer as well as the automatic face recognition system to identify these kind of attacks. This is because if we feed this image to the automatic face recognition system, the automatic face recognition system will verify the morphed face image to both subject 1 and subject 2 in this case. So the face morph generation is a very trivial task. There exist several open source softwares to do that. So as a result, for example, in this slide, I will present a very simple way of generating the face morphing, which is also a very open source. So if we assume that there are two subjects here, one is the malicious actor and the other one is the accomplished. So given the two face images, so we can simply extract the landmarks. Based on the landmarks, we can construct the triangles, and these triangles are wrapped and blended with the certain factors to obtain the morphed image. So when we perform the blending, the factor of the alpha can be varied. So for instance, if you see in this figure here, if we choose alpha as in 30%, then the resulting morphed image is more similar to that of the malicious actor. Similarly, if it is 70%, it is more similar to that of the accomplished. But in case of in the 50%, it is like an average of both face images. In all the three cases, so the morph face images are vulnerable in the automatic face recognition system. That means that if we enroll the morphed face image to the face recognition system, and if we probe both these two face images, for example the malicious actor as well as in the accomplished, then face recognition system will will show that both of these data subjects can be verified against the enrolled subject. So as As a result, this kind of attacks can be used especially in the passport control. So for an example, there is a real case happened in the Germany. So there is a German activist used a morph face image of Federica. So she is an high representative of European Union for Foreign Affairs and Security Policy. So the activist took her photo with the another photo of the Federica. So and then she performed the face morphing. Then she took that morphed image to the German passport application control, and she was very much successful to obtain the passport. That means that the morphed image presented by the activist, activist was so difficult to be identified by the border control or the application process officer. That means that the vulnerability of this morphed image, even for the humans, are at the very high. So as a result, there exist several face morph attack detection algorithms in the literature. So that can be broadly classified into two types. The first type is the single image based morph attack detection, where the goal is to classify a given single image as a morph or a bona fide. So this kind of techniques are very much useful in case of in the passport application scenario, where the second type of the technique is the differential image based morph attack detection. So in case of the differential image based morph attack detection, so there is a luxury of having two images. The one image is from the passport and the other image is from the border control gates. The image from the automatic border control gates are captured from the live subject who is processing the passport. So if the image in the passport is morphed, then we can devise an algorithm that can use both of these images in a different operations in different differential operations to make the final decision on the image in the passport is a morphed image or not. So when we look into the literature, there exist several varieties of morph attack detection algorithms. Even within the single image based MAD, there are like 5 different types. However, even with the differential image based MAD, there are like another 5 or 6 different types. So however, within the scope of this work, we would like to present the analysis on the algorithmic fairness, especially from the single image based morph attack detection. So why we are looking for the bias in the MAD? Because of the three main reasons. The first thing is the all morph attack detection algorithms, especially the single image based morph attack detection algorithms, are based on the face images. That means that the face images are captured with different environment conditions, face images are from the different ages, they are from the different ethnicity groups, and so on and so forth. And all existing MAD algorithms are based on the learning. They use well-known machine learning based classifiers. They use deep learning based classifiers. They also try to use different varieties of the classifier that are basically a data driven. So since these are all data driven, it is quite interesting to see and analyze how these algorithms will behave with different demographic data and other variations within the data. And as I already mentioned, another motivation for bias in the MAD is the sensitivity to the various factors. So since the morph attack detection algorithm should work within the same land square, within the same scope, or within the same scope of the face recognition system, it is highly sensitive to the aging, gender, and the ethnicity bias. So these factors have motivated us to look for the bias in MAD attack detection. To systematically analyze this, so we put forward 3 research questions. The first research question is, does the ethnicity influence the detection performance of SMAD? And the second research question is, which ethnic group is the detection is most challenging? And the third is, among the 6 different MAD algorithms that was evaluated, which one is assumed to be a more fair or more robust across these ethnic groups? So in order to effectively analyze the data, we come up with the new database, and this database is constructed using several publicly available databases. In this work, we try to analyze 4 different ethnicity. Ethnicity 1 is African, ethnicity 2 is Chinese, ethnicity 3 is Hispanic, and ethnicity 4 is Indian. And the morph image or generated based on the landmark based method by considering its easiness and the flexibility, and also the vulnerability of such a morph generation is quite high. So in total, the database what we have generated is having roughly around 24,874 images that are spread across 4 different ethnicity, and we also have a clear distinction of training as well as testing images. So this is the example of our face image from the newly constructed database. We see that there is a lot of variations with respect to the each ethnicity group, and we also took additional care to make sure that the images should represent the passport enrollment quality images. Therefore, we make sure that there is not so much variation in the light, expression, and so on. So most of these images will represent a highly constrained conditions. So in order to effectively benchmark the different single image based morph attack detection, so we try to choose 3 different categories. The first one is the deep feature based, and the second one is the morphing noise based, and the third one is the handcrafted features. So in the first version, the deep feature based, we try to use the existing pre-trained CNN networks which was proposed by other researchers for the MAD attack detection. So we use two pre-trained AlexNet and the ResNet 101, and for the morph noise based method we use color denoising and the residual noise, and for the handcrafted features we use ensemble of features and the hybrid features. So these 6 algorithms are very well shown that they perform well on the several databases that have been reported in the literature. So in order to effectively perform the experiments, we have 3 different protocols. The first is the inter-ethnicity, that means that training with the same ethnicity and testing with the same, and the inter, that means the training with one type of ethnicity and testing with another type of ethnicity, and in the third, training all and testing all evaluation. So most of these experimental protocols are designed such that it can give insights on the variation in the performance, especially when different ethnicity is used for training and for the testing. And to benchmark the results, so we try to use ISO-IEC metrics, that is APCR, BPCR, and also we include D equal error rate. So, and also we particularly use the other kind of fairness metric that is called as FTR, so which is represented as shown in the figure. So based on the obtained results, I am not presenting all results in the total, but the most important observation what we have seen here among all the 6 algorithms is none of these algorithms are robust with the change in the ethnicity. Their performance will degrade to the larger extent when they are trained and tested against the different ethnicity. So this shows that these algorithms are biased too much towards the ethnicity. And once we benchmark the fairness discrepancy rate across different ethnicities here, if there is if the change is less from 10% threshold to 5% threshold of APCR, then the algorithm is said to be a fair algorithm. But as you see here, all the 6 algorithms across different combinations of ethnicity, none of them shows a consistent fairness across different groups. But however, when we consider all 6 algorithms together, we can say that one of the algorithm is good with one combination of ethnicity, and other kind of algorithm is good with another type of combination of the ethnicities. So this again demonstrate that the existing morph attack detection algorithms severely lacks the fairness, especially towards the demographic bias. Well, now based on the obtained results, we try to answer 3 questions. So first question is, does the ethnicity influence the detection performance of SMAD? Based on all the experiments we have obtained, so we see that the algorithms are influenced by the ethnicity of the subjects used for both training as well as the testing. Similarly, for the which ethnicity groups, of course, we cannot accurately say which ethnicity group is more challenging to be detected, because there are several factors will come into picture that also includes the variation in the databases and so on and so forth. But however, almost all the ethnicity groups are quite challenging to detect when the MAD algorithms are trained on one type of ethnicity and tested on other type of ethnicity. So among the 6 different type of MAD algorithms we have tested, we notice that the use of residual noise based method is quite robust when compared to the other existing methods. So that means that if we use the residual noise based method, probably we can achieve little bit of generalization, but however this method is also highly vulnerable, or shows the degradation, especially when trained and tested against different ethnicity. So with this, I would like to end my talk, and thank you very much. If you have any questions, please do contact me via email. Thank you very much.